Good morning, students. So in the last class, we discussed about the system function, properties of jet transforms, system function. What you mean by system function? It is output by input. Okay, it is represented like this. It is in the form of a linear constant coefficient differential equation. So here we are describing the linear constant coefficient differential equation is in the form of sigma k equal to 0 to n a k into y of n minus k is equal to sigma k equal to 0 to m b k into x of n minus k. So uh, by writing a naught into y of n uh, for k equal to 0, and from k equal to 1 to n we will write this. So taking a1 as a naught as 1, so it is yn plus sigma k equal to 1 to n a k into y of n minus k, so that we can extract the value of yn. Okay, from this we can obtain the system function y of n by y of z by x of z is equal to sigma k equal to 0 to n bk into z power minus k by 1 plus sigma k equal to 1 to n ak into z power minus k. This is called a system function or transfer function. Okay, system function or transfer function. System function or transfer function. Okay. Next, already discussed about the time response. These are all some problems we have done. Next, time response analysis of discrete time systems. Okay. So here we are considering a naught is not equal to 1. So here we will write the difference equation in terms of yh of n and yp of n, where yh of n is homogeneous solution and yp of n is called particular solution. So it is a combination of time response analysis of a system. Discrete time system can be written as a combination of homogeneous system and particular solution. Homogeneous solution and particular solution. Okay, next coming to the natural response or zero input response. So here for describing this natural response or zero input response, the solution of the above difference equation with x of n equal to 0. Let us consider with x of n equal to 0. So that is sigma k equal to 0 to n a k into y of n minus k, which is equated to 0. Okay. So it is in the solution of the equation is of the form y h of n equal to lambda power n. So it can be replaced by lambda power n minus k. Y of n minus k is replaced by lambda power n minus k. So sigma k equal to 0 to n a k into lambda power n minus k is equal to 0. Or we can expand this as a naught into lambda power n plus a1 into lambda power n minus 1 plus a2 into lambda power n minus 2 up to a n minus 1 into lambda power n minus n minus 1 plus a n into lambda power n minus capital N, which is equal to 0. Let a naught equal to 1, then it will become this expression, which gives lambda power n plus a1 into lambda power n minus 1 plus dash 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 a n minus 1 into lambda plus a n equal to 0. So it is the characteristic equation of the system. So to find out the roots for this equation, characteristic equation, so lambda 1, lambda 2, lambda 3 up to lambda n are the roots of the characteristic equation. Okay. So yh of n equals c1 into lambda 1 power n plus c2 into lambda 2 power n plus c3 into lambda 3 power n up to cn into lambda n power n, where c1, c2, c3 and cn are arbitrary constants. These are arbitrary constants. After that, depending upon the conditions, if the roots are same, the characteristic roots are same, then what will be the solution? These two are imaginary or complex roots, then what will be the solution? So these are the solutions. Okay, and already done this problem also yesterday, and today. So this is the problem. Find the natural response of the system described by the difference equation y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to x of n minus x of n minus 1 with initial conditions y of minus 1 is equal to y of minus 2 is equal to 1. So this is the given differential equation, difference equation. So y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2, which is equated to 0. Here x of n terms will become 0. Okay. So y of n is replaced by lambda power n, y of n minus 1 is replaced by lambda power n minus 1, y of n minus 2 is replaced by lambda power n minus 2. So taking lambda power n minus 2 as common, lambda square minus 4 lambda plus 4 equal to 0, or lambda square minus 4 lambda plus 4 equal to 0. You can find out the roots, characteristic equation of the roots. Lambda 1 is 2, lambda 2 is 2. See, if the roots are same, then the solution will be y of n equal to c1 plus c2 into n whole into lambda power n. So c1 plus c2 into n into lambda is 2 power. Okay, by applying the initial conditions, y of 0 is equal to c1 plus c2 c2 into 0, that is 0. So c1 into 2 power 0, that is 1. So it is equal to c1. Y of 1 equal to c1 plus c2 into 2 power 1. Okay, c1 plus c2 into 2. Or y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to 0. This is the difference equation. So y of 0 minus 4 into y of n is 0. Then 4 into y of minus 1, y into y of minus 2 equal to 0, or y of 0 minus y of minus 1 value is y of minus 1 and y of minus 2 values are given as 1. Okay, so by substituting 1 at here, 4 minus 4 plus 4 equal to 0, or y of 0 equal to 0. And then if you substitute 1 at the place of n, then it will become y of 1 minus 4 into y of 1 minus 1, that is 0, plus 4 into y of 1 minus 2, that is minus 1, is equal to 0. So y of 1 minus y of 0 value is 0, plus y of minus 1 value is 1. So that we will get the value of y of 1 as minus 4. So that c1 value will become, so y of 0 is c1, so c1 value will become 0. Okay, like that we'll find out c2 value. So finally we'll substitute these values, c1 plus c2 whole power n into uh, minus 1 whole power n into u of n. Okay, then coming to the forced response. What is meant by forced response? The forced response of the system is obtained by summing the particular solution and homogeneous solution and finding the coefficients of homogeneous solution so that the combined response yh of n plus yp of n satisfies the zero initial conditions. So here we obtained by summing the particular solution and homogeneous solution, and also find out the coefficients of the homogeneous solution. Okay, so that the combined response y of yh of n plus yp of n satisfies the zero initial condition. General form of the particular solution for several types of inputs is as shown like this. See, this is the input signal, this is a particular solution. So delta of n means impulse function. So its particular solution is 0. A step input, a step input, that is k, a into m power n, that is k into m power n, a into n power m, that is k naught into n power m plus k1 into n power m minus 1 plus k2 into n power m minus 2 plus k into m. Similarly, an into n power n, that is an into k naught into n power m plus k1 into n power m minus 1 plus km plus km. Next, a cos omega n, a sin omega n, sin, that is c1 into cos omega n plus c2 into sin omega n, where capital A, M, N, and C1 and C2 are called constants. Uh, these are the these are the general forms of particular solution for several types of inputs. Okay. So now we'll see the problem. Find the forced response of a system described by the difference equation y of n plus 2 into y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1 for a given input, that is x of n is equal to half 1 by 2 whole power n into u of n. Okay, so what is the difference equation given? That is y of n plus 2 into y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1. Okay, So here we will write this in forced response. We will write this as combination of these two components, these two parameters, the forced response and uh, particular solution and homogeneous solution. Combination of particular solution and homogeneous solution. That is YF for n equal to YH of n plus YP of n. Your roots are same. Then YH of n is equal to C1 plus C2 into minus 1 whole power n. X of n is given as 1 by 2 whole power n into U of n. Or Yp of n is equal to K into 1 by 2 whole power n into U of n. Right? But Yf of n is equal to forced response C1 plus C2 into minus 1 whole power n plus Yp of n is K into 1 by 2 whole power n into U of n. Yp of n is particular solution, H of n is homogeneous solution. Homogeneous solution is this one and particular solution is this one. Okay, so K into 1 by 2 whole power n plus 2K into 1 by 2 whole power n minus 1 plus K into 1 by 2 whole power n minus 2 is equal to 1 by 2 into 1 by 2 whole power n plus 1 by 2 whole power n minus 1. By simplifying this, we will get the solution like this: n minus 2 is 0 or n is 2. So k into 1 by 2 whole square, if n is 2 means k into 1 by 2 whole square plus 2k into 1 by 2 whole power 2 minus 1, that is 1, plus k into 2 minus 2 0 is equal to 1 by 2 whole power n plus 1 by 2. Okay. Okay, then k into 1 by 4 plus k equal to 1 by 4 plus 1 by 2 or k equal to 1 by 3. So yp of n is equal to 1 by 3 into 1 by 2 whole power n into u of n. Okay, so like this we can find out the particular solution. Particular solution. Okay, in order to determine the values of C1 and C2 by applying the initial condition, that is y forced response of n is equal to C1 plus C2 into n whole power minus 1 whole power n plus k into 1 by 2 whole power n into u of n. Put to n equal to 0, then it will become C1 into minus 1 whole power 0, that is 1, plus 1 by 3, k value is 1 by 3, 1 by 3 into 0, 1 by 2 whole power 0 is 1, that is 1. So y0 will become C1 plus 1 by 3. Similarly, if you put 0, n equal to 1, then C1 plus C2 into, so by substituting these values, you will get y1, y of 1 value is minus C1 minus C2 plus 1 by 6. So finally, y of n plus 2 into y of n minus 1 plus y of n minus 2 equal to x of n plus x of n minus 1. So our y of 0, so that if you put 0 here, we will get y of 0 value is 1, y of 0 value is 1, then 1 equal to C1 plus 1 by 3, so C1 value is 2 by 3. Similarly, you can find out the value of C2 value also. C2 is also 0. So finally, yf of n equal to 2 by 3 plus 1 by 3 into 1 by 2 whole power n into u of n. So this is the solution for the forced response. Next, find the forced response of the system described by the difference equation y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to x of n minus x of n minus 1 when the input is x of n is equal to minus 1 whole power n into u of n. Okay, so the given difference equation is y of n minus 4 into y of n minus 1 plus 4 into y of n minus 2 is equal to x of n minus x of n minus 1. Yf of n is equal to yn of n plus yh of n homogeneous solution plus particular solution. So homogeneous solution is C1 plus C2 into n into 2 power n. Particular solution is k into this is particular solution for this one, k into minus 1 whole power n into u of n. So yf of n equal to this plus this, C1 plus C2 into n into 2 whole power n plus k into minus 1 whole power n into u of n. So substitute these values in the difference equation, that is k into minus 1 whole power n, okay, minus 4 into k into minus 1 whole power minus n minus 1 plus k into minus 1 whole power n minus 2 equal to minus 1 whole power n minus 1 whole power n minus 1. If n minus 2 n minus 2 equal to 0, n minus 2 equal to 0, then n is 2. So replace n by 2. So k into minus 1 whole power 2 minus 4 into k into minus 1 power 2. So like this we will get k value is 2 by 9. So then particular solution yp of n is equal to 2 by 9 into minus 1 whole power n into u of n. So now applying the initial conditions. So replace 0 by n, so that we will get y of 0 equal to c1 plus 2 by 9. Similarly replace n by 1. So y of 1 is equal to c1 plus c2 into 2 minus 2 by 9. So substitute these values in the difference equation. We will get y of 0 equal to 1 and c1 value is 7 by 9 and y of 1 value is 2. Like this you can calculate these values. After that yf of n equal to 7 by 9 plus 1 by 3 whole power n whole into 2 whole power n plus 2 by 9 into minus 1 whole power n into u of n. This is the solution for the forced response. So these are all the problems. We have to do it by our own. By explaining these problems, we can't get the can't understand much. By doing the problem only, we can understand the concept. Okay, so do it as a homework. Do it these problems. Okay. In the next class, we will discuss about the frequency response and analysis of discrete time systems. Okay. With this, I'm concluding the today's class. So in the next class, we will discuss about frequency response analysis of discrete time systems. Okay. Thank you.